Hello, welcome to this video. So in this video I'm going to be talking about education gone wrong and the problem with how physics is often delivered to students within schools, and for my UK audience, within sixth forms or colleges. For my American audience, I'm talking about um, physics as it's delivered for students prior to them attending university. University comes with many challenges, but one of its great benefits is it can, for a variety of reasons, actually give good coverage and a proper introduction to the subjects it's covering. So this video is going to be about some of the problems, how exams distort heavily the way that physics is portrayed within schools, and what we can do to get around some of the problems to give students a much more holistic and a much richer picture of the subject and prepare students better for the actual genuine nature of the subject as shown during higher education. And for this video I will be simplifying things a little bit, but my main aim is to make clear points, so I hope you forgive me if perhaps a little bit of nuance is slightly lacking in parts. So I think the biggest problem, and I think something that causes a lot of confusion really in terms of physics, is when it's presented with a lack of context, which it often is in schools for a variety of reasons. Firstly, there is a shortage of physics specialists, so a lot of teachers in school that teach sciences will specialise in other disciplines and will teach physics as almost a secondary subject, meaning that their expertise within that field are somewhat more limited, so they have less context to draw upon anyway. And also, so much of the school education system is revolved around exams that when you take into account the time required to prepare people for exams, there is actually very little time to teach any individual subject. That's noticeable at GCSE. It's particularly noticeable at A-level, because at GCSE students are doing so many subjects, there's barely time to teach much in any individual one. Whereas with A-levels, there's theoretically much more time available, but whilst yes, more time is given to teaching, so much, well, a unfair proportion, I should say, of that time is devoted towards exam preparation necessarily due to how much priority is placed upon grades instead of actually learning. And so there's very little time to actually cover the physics, meaning anything apart from the core requirements to do well in an exam tends to be left to one side. And to give an example of what I mean by the lack of context, I've got a question here which might be at the start to a GCSE paper. And it goes something like, an apple has a mass of 500 grams, calculate its weight using the equation W equals mg, take g to be about 10 meters per second squared. And there are reasons why I think teaching people about physics, particularly in this case weight, with the goal of answering such questions is problematic to learning. So here are the reasons why I think getting students to answer this demonstrates how much of a parody exams make out of the subject. So firstly, this question encourages people to think of very physical concepts like weight, mass, and G, which is the gravitational field strength, as just variables to which you can assign numbers. The question does not encourage students to wonder what the physical significance of those variables are, such as what is mass. Sometimes another parody is almost said of, well, mass is how much stuff something is made up of, but what does that mean? What is meant by the word stuff? And how are you quantifying how much? Do you mean information? If so, how are you quantifying information? Do you mean the number of atoms? Now, 500 grams, the mass does relate to the number of atoms, but this question doesn't encourage one to wonder how, or how that conclusion was reached, or what the experimental evidence for that is. It doesn't encourage one to think about how we discuss mass in everyday language, and why we might say the moon has less mass than the Earth. We don't encourage that. Also, in terms of a lack of context, one particularly noticeable thing is G. What does G mean? What is the gravitational field strength? Furthermore, what is a gravity? And why are we measuring mass in grams? Could we measure mass in other units? Why are we measuring G in meters per second squared? Why meters? Where did the convention of using meters come from? So a huge amount of context is missing, conceptual and historical. And then also a really key thing to ask in physics, which is heavily encouraged in higher education, but isn't encouraged, sadly, in schools, is the question of, well, under what circumstances can this equation be trusted, and under what circumstances will it break down, and what physics follows when it breaks down? So this equation, W equals mg, for example, is taking G to be a constant. The natural question to ask is, can we always take G to be a constant? And if we can't, why can't we take G to be a constant? What is it about the nature of G that varies? Also, this equation is assuming that the gravitational force and the inertial force are the same. And you can see this if you compare this equation to Newton's second law. Really, this equation is assuming gravity behaves like any other force. But why is the inertial and gravitational force the same? And rephrasing that, why is the gravitational and inertial mass the same? And an answer to that question actually leads to general relativity and the discussion of things like black holes, wormholes, time travel, Cuvier warp drives, and lots of really cool physics that you can start to inquire about when you look at this equation with at least a bit of skepticism. One of the scariest things schools do is they give information and they encourage students to believe that information, whereas schools in an ideal world, and I understand why this might not be so practical, but in an ideal world would encourage skepticism, critical thinking, um, almost demand for proof, or well, in mathematics, for proof, in the sciences, at least some hint of experimental evidence. Because to use an equation without understanding the assumptions behind it, and therefore under which cases it works, means that you're using an equation, but you don't really know whether you can trust it or not. And that's that's a really unfortunate state that many students of physics find themselves in, because the school system doesn't give them any context to equations, doesn't encourage them to question it, and therefore they really have no other choice but to just trust an equation, even when we know, and when I say we, I mean, you know, if one goes far enough in physics, it's known that this equation is wrong. Not just mathematically wrong, it's conceptually wrong. Like, it treats gravity like a force, and gravity isn't a force in the traditional sense of the word. So there are many problems with this equation, including conceptual problems. And another thing in terms of lack of context, which I've kind of hinted at just now, is there are certain things which under certain environments or circumstances are constants. Like near the Earth's surface, G is reliably about 10. But how do we know that value for G? What kind of experiments can we do to test that? Now, fortunately, in this case, students do get a chance to actually deduce the value of G for themselves, but that's small g. If we look at Newton's law of gravity in capital G, no explanation is often given for how capital G, so the universal gravitational constant, no explanation is often given for how that was found. It's not even discussed that Newton's law of gravity, as we write it with G in, was never actually written down by Newton. Newton never introduced the universal constant of gravity. He wrote his equation as a proportionality relationship. He didn't involve any constants of proportionality. That's, you know, completely skipped out, even though it indicates a interesting subtlety in the difference between how Newton thought about physics and how we think about it today, where nowadays we use equals a lot, whereas in Newton's time it was a lot more about proportionality. And I think it's a shame to miss those historical and developmental ideas. And then lastly, as I said, you know, who came up with these equations? And how did they arrive at them? And also, why were they interested in them? Like, why do scientists care about this equation? What is this equation saying? I mean, the interesting thing is, if you generalize it, you can work out the pressure of a fluid above an object. That's important if you're building submarines and considering the pressure of water when you go, you know, deep below the surface level. But again, none of that is often clearly discussed. And all of this sort of lack of context means it's really hard for students to actually understand physics. Because to understand something, you need context. Without context, you just have variables some of which are constants and others of which you were trying to work out. Now, doing experiments goes some way to giving that context, but there is far more to context than just experimentally verifying a few constants. Although experiments can do more than that, but what I'm trying to stress is context is important in terms of philosophical context and what assumptions is an equation making, and under what circumstances can we trust those assumptions, if ever. What historical period was it set in? What was the physics that was believed at the time that influenced the development of the idea and how we used to think about it? How has that way of thinking about it changed? Why do we use particular units? How do these units interact? And in certain cases also a language. So there is a certain amount of German and Greek involved in physics, particularly doing A-level physics. What do those words actually mean? Why do we use them? There is so much more context than simply what is offered often in school, which means students are genuinely confused and very understandably confused about the bedrock of physics, which creates lots of problems when they try to take physics further. So I've talked a little bit about the lack of context, often both given in exam board physics questions and also within the classroom, partly because there is this bizarre and incredibly frustrating confusion nowadays within education between helping students get high grades in exams and helping students learn, as if learning and exams are somehow intricately and innately tied together, which they aren't. But now this slide is going to be on the problems with how exam questions and the school syllabus at large doesn't really encourage creative thinking. In fact, it hinders the development of creative thinking in areas. Now, particularly for this slide, I am simplifying the matter because there are some questions, particularly at A level, that do require creative applications of ideas students know. So in terms of being creative with applications, so being creative almost from an engineering-like perspective, actually the exam boards do a good job at integrating that into the learning. But creativity is a lot broader than being creative with applications, and in a lot of areas of encouraging creativity, the way that physics is covered in schools and sixth forms is heavily lacking. So here's a question that you might find, say, towards the middle of a A-level paper. And it says, using the Bohr model of the atom, explain how an atom can absorb or emit light. And then there will often be some calculation questions based around the Bohr model following this. However, I think that this question demonstrates how constraining the exam system is when it comes to learning. So here are some of the reasons why I think the question above is really a parody of physics. So one thing is that the question doesn't ask how do atoms emit or absorb light. It doesn't really encourage students to bring in various models they may have learnt, or far more importantly, decide for themselves what is the best model to describe this. Instead, the question is incredibly leading. It tells them what model to use. And therefore, it doesn't really encourage students to be that critical of the model. And in fact, I think, at least when I did A-level physics, there was no criticism offered of this semi-classical model, despite this semi-classical model having huge problems associated with it. But even if one, accepts this model, a way to answer this question, which would get students little to no marks, but I think would show superb understanding, is to talk about how the wave particle duality learnt at A-level, particularly the de Broglie wavelength, indicates that electrons might be able to form standing waves, and then those standing waves are stable thanks to kind of interference, and can therefore allow stationary states. But to get standing waves, we need at least half integers of wavelengths, but because electrons are single particles, we can't have a half particle, so we need standing waves where the circumference of the orbit is the size of an integer number of wavelengths of the electron, and that constricts the energy levels. And then I will go into the idea of kind of electrons absorbing photons. But say if a student has learnt some quantum electrodynamics and is like, to avoid the problem of instantaneous absorption or emission, which would violate Heisenberg's absurdity principle, we actually need a superposition of absorption and emission in terms of the electron state. Say if they said that. Now that idea from quantum electrodynamics is completely valid. I think shows a deep understanding of physics. Would the student get any marks for that? No. Even though that kind of idea might be presented, admittedly without much maths, but it might still be presented in popular science books, or discussed in reliable forums. So this question, as it's phrased, and the kind of mark scheme, as it's written, come together to really discourage creativity and thinking out of the box. And as I say, it's partly due to the nature of exams, and particularly that the mark scheme is so restrictive. It's I think really problematic because it encourages students to think. There is a very select way of answering a question. There are very select ways of thinking about things. And I think that's really problematic because then there certainly aren't. And it's disingenuous to encourage that kind of psychology in students. But if we're assessing mainly by exams, then we don't really have much choice. I mean, exams tie our hands behind our back. I think any education system where there is a priority on grades and where those grades are then predominantly determined by exams cannot do physics or mathematics justice. And kind of tangential to what I said, or building upon it, the question doesn't really encourage them to come up with novel results or investigate the theory in any way. I mean, one can take the idea of standing waves to actually predict the sizes of atoms in their ground state, and I think it'd be really cool to encourage students to predict the size of a hydrogen atom and then compare that to the actual size. Now, exams might actually lead a student through that kind of calculation at A level, but the thing is, it's the exams determining what the student does, and not just what the student does, which I think is fair, but very tightly controls how these students to answer it to get the marks. Whereas in higher education, it's the lecturers who write the exams, and because the lecturers are experts in their field, if a student goes off piece and writes a valid answer but something that is completely out of the box or shows very novel ideas, the students in university can still get the marks because they're being marked by a lecturer who really knows their stuff. The problem with the reliance on exam boards is you then have examiners for A-level and GCSE papers marking exams, but they don't really know enough about the subject to award marks if students go off piece. Therefore, they are entirely relying on sticking to a very narrow mark scheme, which is stifling of creativity. And I dislike that immensely. I mean, I dislike it immensely enough that education has become so much about people getting grades as if the aim of education is to prove one's intelligence rather than actually just developing one's intelligence, social skills, creative thinking, and so forth. I think it's a real shame that nowadays education is targeted towards students achieving a letter, rather than there being a primary focus on the skills and a secondary focus on grades. And I think another problem with how physics is introduced in school is well, particularly actually how maths is introduced in school within a physics classroom, and to a lesser degree, but still to a degree, within A-level maths. I mean, at least for standard A-level, further maths might be different, but looking at further maths papers, I think the same criticism can still be applied. School encourages people to think about maths as some fairly rigid algorithmic process. That's a kind of step-by-step process you can follow to get an answer. And that is so vastly different from the actual nature of maths, and that way of viewing maths is highly problematic for students that then go on to university. And the reason that thinking is highly problematic is because, okay, if you're solving very similar problems to problems you've seen before, then yes, following an algorithm that has solved those other extremely similar problems will probably help you solve the problem you're looking at. But, you know, real physics and mathematics looks at problems, many of which are sometimes fairly unique, and some of which, you know, you're researching, and therefore you're looking at kind of new ways of looking at it for which there is really no algorithmic process you can rely on. And instead, what you need to do is you need to understand the logic behind the mathematics, see mathematics almost as a philosophy, and then you need to be able to play with it like Play-Doh. You need to be able to think about it like poetry. You need to be flexible, and above all, you need to be creative. Creativity is paramount in mathematics. Because mathematics isn't an algorithmic process at all. Physicists break away from algorithmic processes and notations all the time. What maths is a way of describing things with logical consistency, and is therefore a form of poetry. And the way physicists use mathematics at university is like poetry, is like a flexible and ductile language. So I think, all of these kind of like criticisms of how physics is covered within schools and UK colleges really comes back down to physics being predominantly assessed by exams, and there being huge emphasis on assessment instead of learning. And I think another thing that is really bizarre about the exam, well, assessing primarily by exams that I haven't put down here, is exams assess students' performance within a 2-hour window, usually. Now, admittedly, students say doing GCSE will do 2 exams. So, okay, that's a 4-hour window. But they have been working with physics for 2 years. So one is assessing students' ability within schools in a subject that they've been working with for 2 years during a period of just 4 hours. And that puts tremendous pressure on students. I think that is deeply unfair to their mental health. Furthermore, exams assess students in terms of what they can do by themselves, which is absurd given that in real life one is never really working by oneself. One is actually working in collaboration with others, or at least within a team. So why are we assessing how well students do by themselves? Why is that our primary form of assessment? That seems to me ludicrous. Like, it, yeah, part of the assessment should be social interaction, in terms of how you're engaging with others, how you're working in a group. It should be research and encourage creativity, and there should be far less emphasis on exams, and also actually far less emphasis on grades. If we could abolish grades, I think to a degree that would do a great deal of good. I think that would be a little extreme, but it does concern me how much school is about helping students do well in terms of grades, and how little it is actually about helping students do well as human beings. But anyway, I'm going to now finish this kind of like video by discussing ideas of what we might be able to do about it, what we might be able to do about the problems with how physics is introduced in schools and sixth forms. And when talking about what we can do, obviously it's easier said than done. But for the point of this video, I think it's worth making some points and ending on a hopeful note about how we can make the future of physics education in mainstream schools and sixth forms better than it currently is. So here are my ideas on how we can change the system. Particularly change form of assessments to help introduce students to the rich beauty that is physics and mathematics. So one thing is we should stop in schools teaching, at least stop exclusively teaching, STEM subjects and humanities as if they are disconnected and independent. I think the attitudes of schools to separate subjects into STEM subjects and humanities does great damage, actually, to both of these categories of subjects. I think the humanities suffers a lot from a lack of knowledge of the sciences. I mean, when I was doing A-level philosophy and ethics, I read one ethics paper that discussed the nature of free will. And it mentioned quantum mechanics, and it was apparent to me, and it still is to this day, that the writer did not understand the quantum mechanics they were introducing, whereas if they had, that might have been a really interesting discussion. So humanities, including ethics, do suffer from a lack of knowledge of science and mathematics. Similarly, there is loads of ethical discussion around science, and I think particularly for physics, there is, well, and mathematics, there is a huge amount to be gained by having an understanding of philosophy and history. So I think, there is natural ties between these subjects because modern philosophers live in a world which has been built with the huge aid of science, technology, engineering, and mathematics. So STEM subjects are a part of their life and drastically affect their worldview, whether they know it or not. Similarly, physicists are people. They operate within a society. They are influenced by the current views of their society and the limitations with how their society allows them to engage with science. And therefore, physicists having an understanding of sociology and history would really help them be very self-aware of the science they are doing and do really good research. So I think it's important that there should at least be, say, one day of every couple of weeks, because I know a lot of schools have kind of like a 2-week rota, so maybe one day out of 2 weeks. Have a day where teachers are getting together and discussing with the students topics that integrate these subjects together. Because these subjects do not work within islands, and teaching the subjects as if they do work within islands is heavily destructive to these subjects. It really does hinders people's development. For example, if one does not understand how to do philosophy, that is hugely problematic in developing physics and mathematics. At least if one wants to be inquisitive, creative, or critical. Admittedly, something that the current exam board and the domination over the subject don't really encourage, but still, in an ideal world, creativity and criticism would be a far greater component of physics, mathematics, and the education of STEM subjects. And I think another thing is encourage self-learning. And this is partly because schools can only do so much to encourage students to learn and explore areas they're interested in. There is only so much time within the school day, particularly for students in GCSE. But I'm thinking when it comes to students learning, And particularly if the students are kind of doing A-levels and would like to study that subject or an adjacent subject further at university, such as if a student's doing physics at A-level but wants to do engineering at university, I think for those students, definitely more emphasis needs to be put into the classroom in terms of encouraging self-learning. So maybe once every 2 weeks, starting off an A-level class by getting students to discuss what they have read that week. Maybe attaching links at the end of PowerPoint slides to various articles or helpful PDFs that go into greater depth than what is covered within the class. Students could also be encouraged to watch MIT videos. I mean, MIT is a brilliant organisation in that they release a lot of their core lectures. I mean, not the supporting lectures, material or homework, but the core lectures are, much of these are released for free. And you can actually watch them for free on YouTube. Also, there are open access journals. There are sometimes PDF copies of kind of like books where the book is a very old edition, but much of the material is still relevant because our viewpoints of physics do change. But I mean, we still use physics from hundreds of years ago because it's still useful, even if we have more modern understandings of physics. So, a book that was written 50 years ago in physics is still likely to be very useful and largely reliable, unless it's on a really, really super specialist topic. And also, I think there needs to be governmental work put in terms of reducing exams, at least the percentage of grade determined by an exam, and push assessment towards more project orientated style of deducing how well students understand material. Because with project, students have a much greater chance to look at the area holistically, to bring in philosophy, history, but also to be critical of ideas, to challenge things. I mean, I know there's, for example, an EPQ that students can do. I think EPQs are brilliant. But I think a smaller version of an EPQ integrated into A-level physics and mathematics would really help enrich the subject for students. It would also give them a chance to explore an area of the subject they are particularly interested in that perhaps the syllabus mentions, but doesn't go into too great a depth on. So, for example, the A-level physics syllabus talks about particle accelerators and compares cyclotrons to synchrotrons. Students could do a whole project on the development of particle accelerators, and then also talk about the idea of building a particle accelerator on the moon, which China is currently floating about, or whether building larger and larger particle accelerators is a good investment of money for research, a debate that is happening right now in physics and is very current. And also exploring things like how finances impact research is really helpful because it reflects the real world. Again, bringing learning within a broader context actually prepares students for the real world and teaches them much more about how these subjects actually function. And also, I think projects encourage discussions, they encourage teamwork and collaboration a lot more than exams. And teamwork and collaboration is critical because it's actually how the world works. We are a social species. So why do we assess students by work they do in complete silence, where they are not allowed to communicate with others? I mean, it's genuine insanity. So yeah, I think definitely more project stuff, less exams. Also for students' well-being, mental health, distilling the pressure rather than have it concentrated within a narrow band of just 4 hours would really, really help students. Now these are just kind of like my own views. Admittedly, I have oversimplified things in certain areas. And it's worth saying I'm not critiquing the work that schools and teachers in schools do. I'm raising well, I'm trying to raise a discussion around how can we improve education, and are exams really the best way forward? Because I think it's very important to have these discussions. Because I think for too long the dominance of exams has been accepted, the dominance of grades as the focus of education has been accepted, and I think both things are a tragedy. I think a dominance of grades is perhaps slightly inevitable because competition is part of a social species. So I don't really know a way around that properly, but I think definitely encouraging project forms of assessment would help students see the value of education far beyond achieving letters. So anyway, these are my views. I would encourage lots of discussion. I could be wrong about some of the things I've said. I could be wrong about all of them. I know I have simplified things, so yeah. There's only so much room for nuance within a YouTube video, but hopefully this video is part of an effort to make education and learning much more enriching, enjoyable, and fair for students. And so I think it's really well worth making this video. But I wish you a brilliant week ahead. If you're in the UK, definitely have an umbrella. Certainly, if you're in Scotland, have an umbrella. But I wish you a brilliant time forwards. Keep exploring the wonderful universe. And if you are in schools or colleges at the moment, don't let grades let you down. The brilliant thing is the universe really doesn't care about grades, so don't worry that much. The universe will continue its marvelous magic. Anyway, so I wish you all a brilliant future, and I hope you really have a fantastic week. And continue exploring the universe independent of our rather confused educational system.